So my name is Charles Milana. I'm going to be talking about doing high throughput analytics with Cassandra on Azure, offered by Microsoft. And if Luke was the witch, I'm something much worse. So principal dev lead there. And how I actually joined Microsoft was through an acquisition of a company called Metrics Hub. And what we did was we kept cloud services running for the absolute lowest cost, and we would help customers on any cloud platform. And the way we would do this is by ingesting large amounts of data, analyzing it, and taking actions. So what that really meant and what our value proposition to customers was all about the live status. We always had to gather the metrics for our customers, aggregate them, and expose them as quick as possible. People love the very real-time, high-touch dashboards. We also helped with a good deal of cost awareness, which meant that we would understand how much the cost was impacting people's performance and their actual deployed out virtual machines, and whether it be private or public cloud. They would then analyze those metrics to actually give alerts, notifications, let people know when something's going wrong, something looks out of normal, that type of thing, as well as take actions automatically. So stuff like this could be scaling virtual machines if you're in the public cloud. It could be things like restarting other machines that have anomalous metrics or reporting any kind of unhealthy activity, or sending emails, running scripts, that type of thing. It would all be based on these metrics. And because customers expected this activity to be as fast as possible, it was really important that whenever we analyze our data, we could act as quick as possible. And kind of here's a quick little example of the current Azure portal with some of these same types of ideas baked into it. You can kind of see like a dashboard here with the metrics showing what your CPU looks like in real time, as well as the ability to configure actions in response to it automatically. This is the type of UI experience that we have in Metrics Hub. And looking back, for our company, we originally started very small. You can see the trickle in the very beginning. And then kind of as we expanded our feature set, we used Cassandra to store all of our data. We were able to see a very rapid growth of customers. Here it's over 2,000 enterprise customers in just 6 months leading up to the acquisition, which was about a little over a year ago. Since then we've been part of Microsoft. But this entire time, kind of we were hanging on by the seat of our pants, getting more and more data to actually analyze and take actions on it. And kind of, I took some numbers here from right around acquisition time. It's about 200 million data points per hour and peaks of 80,000 data points per second. And for us, kind of making sure that we could actually scale to this point was something that we could do very quickly and very cheaply. Because our product was very targeted towards about $100 per server per year, which meant that we couldn't have very expensive data technologies. They couldn't all be SQL boxes, that type of thing. We had to be able to scale per node very efficiently. Here's just some, put that number into perspective of how it can get so high. For customers that are higher level SKU, that would be 1,000 data points per virtual machine per minute. For each endpoint that we monitor, whether it's CPU, GPU, website, that type of thing, it would be 12 data points per endpoint per minute. And as you get larger customers, they could have 5 virtual machines, 100, 1,000. The amount of data that we're ingesting can get very, very large. And for all of this, we had to aggregate it, analyze it, and then take actions based on those metrics in as close to near time and real time as possible. So, say getting all this data and doing ETL offline, doing MapReduce jobs offline, that wouldn't really work for the scenarios our customers wanted, and really was what our differentiation was in the market. And kind of, again...
Did your data come from the Fabric MDS logs?
So, not our case, no, because we were outside Microsoft at the time.
Oh, they're not.
Yeah. So outside Microsoft, so we'd collect data via agents installed on the box, as well as outside monitoring, as well as plugging into APIs. So if we were hosted like an AWS or Azure, we would plug into the public APIs, basically fetch down like how many machines are there, are using S3 or using Azure Table Source, that type of thing, and mix that in with your virtual machine.
So your solution is cloud agnostic.
Yes.
Good, thanks. And everything is Cassandra based too.
Yes. Cool. Yeah. Well, I'll talk about that. So we have, as part of that, we evaluated several different technologies. I mean, that's kind of a big part of the NoSQL movement is actually choosing the right database for the job. Sometimes that's Cassandra, sometimes that's SQL, that type of thing. So like the 3 main ones we looked at were Redis. That was the best performance by far. I mean, you can do aggregation in memory, blazing fast, really powerful literals, but absolutely terrible clogs. In our case, we got all this data, but the vast majority of it was cold. It made no sense for us to pay to store all of that in memory or even any kind of quick storage. Next thing we looked at, costs. So the cost of goods.
Cost.
Yeah. So yeah, so it's just for each customer, each server we monitored cost us like $5 a month, that type of thing. Just didn't really work out economics-wise. We then looked at SQL. There are some big players out there, like New Relic has done a few blog posts about how they use MySQL to store large-scale metrics. And you can do that meaning rolling tables, creating, dropping. There's a lot of good tooling support out there for SQL technologies. There's a lot of really rich libraries, but again, like when you start getting to the large number of like the huge amounts of data that's coming in, it gets hard to scale, really with a smaller engineering team, which was our case as a startup. And kind of the last thing that we landed on was Cassandra, and for that, we were able to find a way to do aggregation on writes, and I'll talk about how we do that with SQL, which made it very easy for us to scale to these huge numbers very cheaply. In the end, like $20,000 a month hosting cost. So, yeah, kind of some more benefits for us was that it grows horizontally. For us, you double the nodes, you basically double your capacity, and you can kind of trace. Imagine like that chart of our customer growth was the same thing for Cassandra nodes. It was 1 node, 2 node, 4 node, 8 node, 16 node, 32 node. That's basically how we scaled, how we respond to customers. And we could add and remove these nodes with no downtime, which also was a huge plus because as we're monitoring customers' real businesses, if we go down at any point, can't take those actions that we promise, we're out of SLA, we lose customers, they're very unhappy. Also, along those same lines, it was extremely available. And what that meant for us is no single point of failure. There's nothing like a name node, and also the replication factor. It was easy for us to have not have multiple single node failure not cause an issue. And by plugging into some of the infrastructure in Azure, we were able to do that in a highly available fashion. Yeah. And then some of the more benefits that we enjoyed was really very limited operations costs from a human point of view, which meant adding new nodes was just a few minutes. We ended up writing a script that could stand up a new node, join the ring in Azure pretty easily. And also once we had tuned our configuration and tuned our write and read patterns, we were able to just add new nodes, increase our capacity, and just not go back to it for months on end, which is really important because we were able to get basically this huge data storage technology without having to constantly invest our own engineering time, our own operations time. And doing that allowed us to really focus on a lot of other components of our business that would deliver value to customers. Yeah. And kind of one of our favorite things based on our own personal experience is that we were able to do aggregations on write. And that means no jobs were required, which if you ever worked on something where you have jobs running in the background, one job breaks and you wonder why you're not taking aggregations or alerts, it gets very tedious at scale to kind of manage. Not to mention you're not getting real-time data in most cases.
What does your operations team use to monitor these metrics?
Metrics Hub. So all the Cassandra cluster was running on Linux virtual machines in Azure, and we used Metrics Hub ourselves to monitor. So we basically had like a side environment just for us to use to monitor our own production environment to test out features, and that's how we'd actually get notifications and take actions for remediation. Yep. So basically, what that would mean is when we would persist the data, it would already be aggregated, like in its final form, across multiple nodes or multiple time ranges. That way, we don't have to say asynchronously collapse down multiple events into a single aggregated record. Yeah, is that? Yeah, and then kind of for us, that all goes back to our big focus was to minimize operational load for our team. And also for us, yeah, the great perf and cogs in Azure. So the full architecture was 68 virtual machines, and that's a mixture between the platform as a service offering and the infrastructure as a service offering from Microsoft Azure. You kind of here is the full, kind of opening the kimono, this is the full architecture of the Microsoft service. On the left-hand side, you have all of our clients that are actually feeding us this data, to which we're ingesting. It comes from customers' websites and their clients' browsers. It comes from their virtual machines. It comes from their public APIs for other public cloud providers. We get all of this data. It comes in via one of two ways. We're either pulling it from our worker, if it's a public API, or it's being pushed to us via our public API using just standard OAuth from agents that have installed on the customer's local box. And those agents would support Windows, Linux, or anything like various flavors. And all that data is basically coming in, and it's exclusively, all metric data is being exclusively written to the Cassandra cluster, which is 32 extra large virtual machines, Linux-based Ubuntu. in Azure. Also, we kind of, to what I mentioned earlier, we did use the right database technology for the right job. So for us, that meant for our job worker role, we use table storage, which is a standard REST key value store available in Azure. Super cheap, super scalable, super reliable. And then for user data, for like logins, passwords, that type of thing, we use the SQL database. And that was only because we cared about transactions, we cared about being able to do joins and indexes easily. But all that data is relatively small, whereas we had dozens of terabytes in the Cassandra cluster.
So those Cassandra run natively on Azure?
Well, you can stand up Linux virtual machines, fully support on Azure, and then in those virtual machines you can run Cassandra. For us, it was a custom script that we had written to install the Cassandra cluster on Azure. Wasn't something offered, but the Linux supports fully.
But kind of like HD Insight is Apache running natively on Azure.
Yes, yeah.
So does Cassandra do that too?
No, yeah, there's no Cassandra as a service offered in Azure like the rest of machines.
Does your multiple data center, does it run in different regions as well?
Yeah, so we had components in US West and US East. The Cassandra cluster itself, we ran only in US West with the ability to fail over with some minimal data loss to US East. And I'd say when we first got started, it was a lot harder to do cross-region Cassandra clusters. I know that people do that in Azure now. There's some tricks to get it working nicely, performantly, but it can be done. So yeah, and then kind of.
So this is a service that is offered to any Azure customers to monitor their subscriptions and service?
So it was still offered publicly as a separate product up until the very end of last year. Now it's rolled into the normal Azure portal. And I'll show like some pictures, kind of what it looks like now, as well as how you can kind of monitor.
Congratulations.
Yeah. So these components here are platform as a service, which again is completely stateless web worker role, like one-click deploy, handles all the upgrades, completely elastic scale, which is the main reason we actually chose Azure was availability of that service. And then we have infrastructure as a service, like just VMs, just like EC2, which is how where we install Cassandra. And then we use the services or software as a service offerings for table and SQL directly from those other components. And kind of, again, to that point of everything is super operationally efficient because of these decisions.
You use the blob
at all? Only for disks. Only for block for disks. But yeah, as part of that PaaS component, all of our application logic and code lives in stateless machines, written in a mixture of C# and Java. And there'd be absolutely no data stored locally on these disks. Like in Azure, if you use PaaS, it reboots, your disk is gone, so you can't store anything locally, which makes it it's a very strong impetus to make your code very scalable, very elastic. We don't have to worry about patching the OS. That's handled automatically. We don't have to worry about hardware failures. Automatically brings down and brings up things called upgrade domains to handle that for us without impacting our capacity. They have two components called web and worker role. Web has an endpoint, and a worker is used mainly for offline processing, has no endpoint open. And kind of, we use these components that had all of our application logic, and then basically we outsource all data storage and processing inside the Cassandra cluster. And kind of, to talk a little bit quickly more about that, is these platform as a service components, they completely scale horizontally. So you can either use API or portal, drag the slider from 1 to 30 nodes, and you have 30 nodes. And it automatically handles deploying your code and all those virtual machines, standing it up, adding to the load balancer, running health checks, all of that is managed for you. Which even if you have a pretty great Chef Puppet setup, it's not that easy. Even if you go to the full automation side of IaaS. And kind of like I mentioned earlier, a lot of components of this would be managed by the platform, including recycling, health, that type of thing. And for us, we happen to use Visual Studio for our deployments, which is just, again, one click, push, and it will deploy. And you go to something called the staging slot. You can verify it, basically deploy 2 instances of your service. So it's completely stateless. You can test on the staging one, click one button, and you swap. And that lets you actually use basically it will become the production slot. It makes it very easy to kind of deploy every day, which is what we did. Now the interesting part. So the Cassandra cluster would maintain all our states for metrics and time series data. And this is very disparate. Some of these would be log records, individual rows. Some of these would be CPU time, memory usage, latency for our endpoint, that type of stuff, all shoved into this one Cassandra cluster. The very basic schema. I'll show that. And this all ran on 32 extra large Linux virtual machines in Azure. And again, that same thing started 1, 2, 4, 8, 16, 32 nodes. We actually just provision those. Not as easy as the PaaS component. Some human sweat involved, but still relatively straightforward in public cloud. And the way we actually architected this in Azure is a little unconventional. So what we do is we had 32 nodes, and we would have 8 pods of 4 nodes. And each one of these pods would basically represent something close to like a scale unit for us. And they would say, for example, have one endpoint between the 4 exposed. We'd have a set of ACLs for each of them. They're all on one private network. But we did this mainly to focus on availability. There's some, you wouldn't, if you were super performance conscious, you wouldn't go this approach because you'd want like a cluster aware client, which this would prevent you from doing. But for us, our big focus was on availability because that was our primary promise to customers.
What would be like the quorums you'd be looking for?
So
if you are.
Yeah, so for us, we do replication factor 3, and we try to write to 2, read 2 or read 1, depending what the query was.
Oh, so each of those set of 4 would be like a local quorum.
So we didn't make Cassandra aware of that. Because they're all they basically were all very close. Like all those nodes would be deployed in the same region. The main reason we did that is for availability of the IP address or the VIP. So that way we would have 8 VIPs, because kind of what you could do is you could expose all 32 behind one VIP, but with 32 different forwarding rules. But the problem for that is if that one like IP address goes down, the whole node cluster would go down. This way we have 8 different outputs to the internet, which makes it much more resilient to individual failure.
So using virtual nodes,
Virtual networks and virtual machines.
No, we're using the Cassandra virtual nodes.
Oh, no, we are not. So for us, we kind of burned in pre-virtual nodes existence for us customers. So moving to that was basically too hard for us to do once we had it that way.
So did you slice all your customers across those 8 pods, or did you put some customers in each of those pods?
So we would basically, in our partition key, we would account for customer ID, which would allow us, like one customer would be smeared over across all the nodes. But we did some bucketing because we ended up with customers too big for one node. And I'll talk about that kind of in our schema of how we do that. But, yeah. So kind of we have here each pod is 4 nodes, single load balance endpoint between all 4 nodes. Our clients would treat each endpoint as basically a single IP address or single host name to connect to. And our clients would basically handle blacklisting any particular endpoint. And that way, basically, we can have smaller sets of failures within Azure Data Center. Say they're doing system maintenance or there's some kind of hardware failure, power outage. And by choosing these individual components, they'd be basically spread throughout the data center. So we'd have much more resilience in the case of failure. But again, kind of if you're super performance driven, you wouldn't want to go this approach. You'd probably want to have expose all of the nodes in your cluster and use a cluster aware client so that you're going to improve your performance by connecting directly to the node that services that partition range or key range. Within each node, the way that we structured it is we had 16 mounted network drives, not ephemeral drives. And we actually made this decision because we weren't I/O bound based on our workload. And by using the network back disks, it made it very easy for us to do potentially regional failover in the event of a disaster. And kind of I talked about the data disks are automatically replicated by the platform. So I have 3 copies locally. So from US West, they're spread out in I think like 3 different availability areas of the data center, as well as 1 remote. So each region has a pair of a remote location. And that's mainly what drove us to go with our data files on these network attached disks. As performance optimization, we had played with putting like the commit log on the ephemeral drive. It didn't really give us that much of a benefit in performance. We just kept that on the drive as well. And for us, yeah, like I said there, the VM drives actually gave us really good throughput for our particular workload. Like everything, you want to test it very thoroughly to make sure you have the configuration that works. But very append only, very write heavy, like 99% writes for operations works very well. All our VMs end up CPU bound, saturate CPU well before disk.
Should VM clocks are not synchronized?
Yes, so like on each node, basically we also had a kind of custom script that would run to try to get the clocks closer, because you can observe clock drift, like particularly in a virtualized environment like AWS or Azure. But if you ran scripts to basically keep the clock drift within 1 or 2 seconds, And for us, since most of the data that goes to Cassandra is all metric data, being fuzzy was okay. So if we drop a CPU record here or there was okay. So that class is definitely something to pay attention to.
How many transactions per second? Do you get on 32?
80,000 operations per second is peak.
That's kind of adequate for the kind of code that you do.
Yeah. So that for us, like since we're very, very write heavy, Cassandra is absolutely superb for that. So getting 80,000 is no problem. But if you're very read heavy, like say you're 90% reads, you're not going to get anywhere near those operations per second. But you should kind of make sure that the data pattern makes sense to be Cassandra. Yep.
You talked about availability pods. Each pod is a cloud service,
Yes, a hosted service.
and then all the 32 nodes in one person.
Yep.
And how have you put them in different fault domains versus upgrade domain to survive either a crack value or?
Yep. So I say very painfully, and only because which is good that information is exposed to you. So like not everyone is familiar within Azure. There's a concept of an upgrade domain, which basically represents like a percentage of your machines that the platform may take offline during system maintenance or system upgrades. And there's a fault domain, which basically describes like physical placement and two different fault domains, like on a different power supply, on a different network connection, on a different door. So you'll want to say spreads and stuff across upgrade domains and fault domains intelligently, so that if you see a failure or a system maintenance in one of them, it doesn't bring your cluster down. Exposing all this from Azure platforms actually makes it pretty easy to do it. You have to make sure you choose your key spaces very carefully on each node. For us, there were situations where, like, if a certain reboot sequence happened, we had no guarantee that we would still be up. But basically, by doing these pods and choosing the key spaces, like diligently, like this one goes here, this one goes here, we were able to kind of get when there was a rolling upgrade or a smaller fault, we didn't have downtime. It took a lot to get to that. So our column families to store all this data was incredibly basic. Four values. RK, CK, which basically are encoded strings, a counter, and a sum. We did some other modifications I'll hint at the end. But this basically allows us to very easily track any metric you can think of and do all the aggregations at write time using the Cassandra counter functionality. And as an example, you would do an update like this to have a real-time running average of whatever metric you want. And you can also do in aggregation across several nodes or regions or tags or anything like that using the same approach, kind of via the data model. Make sure you model it correctly, denormalize massively. One record, one data point for CPU may become 18 runs, and also why you end up with such high write volume. So like, here's an example of, we'd have a different table for each aggregation type that we care about. So say a 1 minute data point versus 10 minute versus 1 day. We had like 3 hours, 15 minutes as well. And basically whenever you get a new sample, it's pretty basic. You keep a running total and a running sample count. And you basically update the record based on some RK, which is a string based on both the customer ID as well as the metric that you're analyzing or the data point that you care about. And a CK, which is basically some tags may associate it with it, and timestamp. And just by doing this, we can basically use a single read query to read all the data back, or more importantly, we can do a bunch of writes once, and then all of our data is aggregated at rest.
So as a customer, when I log into the dashboard, since each of these are happening in each of those pods, someone have to reconcile all of them and present it to me information.
So but generally, when we do the dashboard, actually have like several individual, very small calls to construct the whole thing.
Okay.
Each of those may be routed to different locations. So like a single chart you see may actually involve 4 queries. But by doing this, each of those queries are so fast, with such little deviation, you actually can present a very complex dashboard very quickly.
The metrics data beyond a few days is not very useful.
Yep.
So use the TTL to kind of expand the data, or you kind of truncated the table to the or whatever.
Yeah, so you can't use CTL with counters, or at least the version of Cassandra are wrong. I should know the support now. So for us, that's all manual hacks we kind of have. Depending on what type of data, what aggregation level, it has different retention desires. Like for the 1 day aggregation, I do keep that forever. For 3 hours, I probably want to keep that for a long time as well. But 1 minute, I don't really care about zooming into the minute granularity like 6 months ago. So like for 1 minute, 5 minute, 15 minute, we have to clean up. And for that, we would do that by actually cleaning ourselves. So we very carefully truncate, and you have to wait for compassionate payload. And that was by far the most difficult thing from a scale point of view, because that would make it incredibly complicated actually.
When would these update values actually run? Are they part of the writes itself or just separate
Yeah, so that's kind of there's no jobs at all. So if you imagine like we have an agent installed on a virtual machine, it would upload, say, a set of 50 metrics that would come to our web server. Our web server would prepare batch SQL statements and just send to the server in one shot.
and then run this?
Yeah, so like we actually don't even care about individual samples. We only care about the aggregates. So in that case, when we would actually write, we would write all of these queries, and that would guarantee at that moment all of our aggregations of real time. So that was kind of because it's like if you have jobs that scroll back in Cassandra, you have to worry about like I write 50 records, and then I have to read all 50 records, and then write more. It ends up like messing with the performance characteristics. But here we can stay really focused on only ever write. And counters have some stresses and some idiosyncrasies associated with your Cassandra cluster that require some kind of handling to get everything off the ground working well. And you probably wouldn't want to use like counters for things that have to be exactly precise. Like, we couldn't use this for like your bank account balance or something like that. But for stuff like metrics or time series data, it works very well because you can live with the fuzziness. If you lose a sample, it's off by 5, that tends to be okay for your workload. You can kind of hear this example of how you actually would read it from a CQL statement. You basically choose the customer range, say based on RK, and then you choose, and if you imagine what this actually looks like in Cassandra, it's one row for a given customer and metric and tags, and each column is time. So you basically jump, and then you read a set of columns in that row. And for that reason, it's very, very fast. It's a single statement. And you can scale, like, if you want a page, you can page on top of that as well. You can read like 1,000 block chunks. Back then, we didn't have any fancy drivers, so you'd have to get the previous CK and send it yourself again, which wasn't super performant. But yeah, via this approach, you can basically very quickly show a chart which shows CPU over time, distributivity over time, cost per customer over time, like many of the metrics that our customers care about, by just doing this single query.
So that particular example of where you have timestamp as a column, individual column. So how would you define that in SQL or create tables and tables?
So this is literally exactly what we did to create the table. Like this. So that's kind of like they abstract a little bit away from you. So if you go look, from CQL's point of view, we don't know what's kind of really going on. But if you go look at the actual like old CLI commands, non-SQL, to look at your table, that's the layout that it actually has via sparse table format. And for us, one important thing that reminds me is if your columns get more than a million, bad stuff starts to happen. So if you use an approach like this, you can never really have a single row get more than 1 million. Otherwise, like compaction starts blowing up. So
that does not show up in this syntax. You have to.
Correct. Yeah. Exactly. Yeah. So it's like we know like, you got to use SQL this way, but underneath is actually the layout that it does for you. Lay down a bit. Yeah.
So customer name is the foundation.
Yeah. So it would depend. Sometimes we use customer. So it depends. Kind of what I was saying. It depends a little bit. It'd either be just customer name or it'd be customer name with some declaration. If the customer is like too big to fit in one partition. It's like if we imagine we have one customer who accounts for 25% of our metrics, if we sent them all to one partition, it would not behave well with 32 nodes. So for those ones, sometimes you decorate that value with like either a hash bucket or a type of metric, maybe like system or endpoint, like cost, that type of thing. That way you actually don't all send everything to one single partition. You basically crush that machine.
All new machine you have, we're all new to that, like 1 month data and back it up. So
Yeah.
It's like it seems like your data processing is going to.
Yeah, so it depends on what table you're looking at. So like for 1 minute, basically we got to clean it up relatively quickly. Otherwise, we'll hit. Basically, for 1 minute, the million column thing is a clock that once you cross 1 million, your cluster's going to die. For us, at least for the hardware that we ran on. So we always have to make sure that we start cleaning up columns whenever the number of records would approach that value. And also, there's cogs associated with like space. But for like the 1 day thing, we just would never clean it up. Basically, like compliance would be the only reason you would actually truncate that data table because it's so small. It does so many updates every time you do compaction, it shrinks the size based on the counter.
So when you say for the 1 minute, do you have a cron job, like you just constantly logging the release, or do you have some kind of sort of function versus or are you constantly?
So basically we had a jobs infrastructure, which is how we would like probe endpoints and like pull cost information from public cloud providers. That same jobs infrastructure, distributed jobs, that would actually go and do the truncation for us. So basically a cron job as opposed to on-write. So that's how it would work. For us also, you can always like take the data. It's very easy with Cassandra, like it's so clearly on files. You can take the files and just copy them out if you want to back up, which we would do frequently when we do like major changes, just in case we had an issue. Kind of some hard lessons that we had when learning on Azure. The first is static private IPs are a must. So when if you ever had a reboot or an outage, confuse the cluster pretty bad. The same node would come back and start advertising. And kind of there's Cassandra configuration I think that fixes against this, but it's kind of like when you go to the doctor and say, "Hurts when I do this," I said, "Don't do that." So we just made it so IP never changes instead of trying to figure out the correct Cassandra configuration, and that's pretty easy to do with the virtual network functionality in Azure. And what's cool about that too is you can stitch together all kinds of different virtual machines. Like Windows, Linux doesn't matter; just have one virtual network. Also, we had to monitor performance very carefully because once your cluster starts tipping over, like CPU, disk, memory-wise, it's really hard to rebalance the cluster. So, like we lived this once, very late night, through the night, kind of where your CPU gets like 75%, but you have too much load. Like, say a big customer signs up. You try to rebalance. If you try to rebalance your cluster, that's also a very taxing operation. If you're already on the edge of tipping, you will tip at that moment, and then your rebalancing takes forever. So, like, we had to do all kinds of horrible hacks to get that to work whenever we enter that state. So, like, that's kind of where I always want to make sure that you have ample breathing room, and that when you're approaching your limitations, you're actually doing a certain capacity.
Was that on Cassandra or Azure? The difficulties that you faced?
For this, the second one, it was Cassandra. It's like if you have, say your nodes are like 90% CPU, and you try to go from 16 to 32, it's then copying like 20 terabytes all over the place and rebuilding all this stuff. That operation is super heavy. It'll just drive your CPU to 100. At which time, like customers will start seeing timeouts. You'll start like dropping commits. It's like, and then like it tends to cascade very quickly, where it's like everything's fine, then you just tip a little bit too much, and then everything kind of falls to the floor. No, that's been just that's probably true for like any technology like SQL. If it's at 95%, you try partition, it's not going to go well. Kind of, last one. This is true for Azure or AWS. Is that you want to fit your cluster to the platform, and kind of this is what you guys brought up earlier about the upgrade domains, fault domains. You want to basically make sure you pin your cluster configuration to be as aware of the platform you're running on, so that whenever there's maintenance, hardware failure, that type of thing, that your cluster doesn't go down. It's not as much a problem if you own your own data center, you control all these variables. But if you're kind of up in the public cloud, you have to make sure that this information surfaces to you and you actually configure your cluster around that set of variables. Kind of just have some metrics kind of that come out from some load testing of Cassandra on Azure, which has some interesting conclusions and recommendations for anybody that's going to go look at running Cassandra there. You can do it. You can do this super huge scale. Just to kind of be aware of what's going on. So like here is a single node with 4 disks, RAID 0 configuration, no read cache configured. You can see if you're very write heavy, you can see how awesome it does. Right? Like latency 99 percentile, 8 milliseconds, you do 20,000 ops. As you add more reads, it's going to do not as good. That's a function kind of just the technology itself. You can see the median latency, the 95th, 99th percentile start going higher. Still very manageable, still perfectly acceptable for most workloads. We just again, you want to make sure you choose the right technology for your workload. Also, you have 4 disks, RAID 0 with a read cache. recaches the functionality that Azure exposed for the individual disks for basically your network-backed disks. It can fold stuff in so it'll be much closer to your machine. And there's some logic associated with that. And what that actually helps you do is that improves your read performance if you're a very read-heavy workload substantially. This difference would go away, say, if you ran it on ephemeral drives, which is also possible to do in Azure. Just we didn't do that. It was much easier to use network-based drives. We could use that for DR, be able to tell customers, hey, if West US burns, East US is still available. That was a very valuable component that we got for free, just checkbox. Kind of the network-backed disks, which is very kind of beneficial and luring for a small start. Also, what's interesting is you have JBOD versus RAID options for your actual data file configuration. If you're very write-heavy, you definitely want to do JBOD. If you're also pretty read-heavy, you tend to actually want to do RAID configuration. It's kind of based on these tests. So here's an example of some multi-node tests. 4 nodes, replication factor 3, perform read and writes. And for each of these nodes, you have 8 disks, and we're RAID 0. For Metrics Hub, we were actually 16 disks, RAID 0. But you can see kind of what the performance looks like. And again, if you're very write-heavy, its performance is very good. As you get more read-heavy, there's a little more contention. And again, that's a function of the technology, as well as network disks. If you're read-heavy, you probably want to use SSD, local type thing. You kind of see the variance and stuff like this. And I think we'll share out the slides afterwards, so you can kind of look at the numbers a little bit more. And just kind of, as an example, here is kind of the Azure portal that they expose for if you run virtual machines in Azure, the new version, which is actually released through virtual machine support on Monday. You can use this to monitor your set of virtual machines for clusters. See the CPU, the disk read write, the network in and out. Kind of like our Metrics Hub product you can't sign up for it anymore, but you come here, you kind of see CPU, that stuff. See kind of the things that stick around. But more importantly, it's now super easy to run large sets of virtual machine deployments in Azure. There are new concepts called resource groups and resource manager templates. What they let you basically do is group together these virtual machines, manage them together, and see aggregate views of CPU across them, so your Cassandra cluster. However hard Cassandra is, the example I have here is from a SharePoint farm, an HA SharePoint farm, which anybody's ever done. It's way harder to set up than Cassandra, and it gives a pretty good experience for configuring it very easily and managing right in Azure portal natively. So if you guys are interested, I recommend giving it a try. Kind of play with Cassandra there. Yeah, so kind of we have more free-form questions and answers now.
So what's your
data size? Let me see the exact number. Somewhere between 20 and 30 terabytes for the whole thing.
Do you have ever experienced any no repair forever?
Yes. So also as you get really big, just if you have the column limits, as you end up with a ton of data on your disk, bad stuff starts to happen as well. So that's kind of also we watch very carefully, and at times we actually split not due to write throughput, but actually to decrease the total data size on disk, to simplify compaction and node repair. And for us, it's not as super important because the main reason is again, some fuzziness is okay. So it's something really bad has to happen if you have to run a full node repair. But if you have more sensitive data, it's more consistent with how you're running more frequently. You be very careful with data size.
So for the SQL Server, what kind of redundancy do you use? Do you use always Flutter or Live50?
So for us, we just use SQL Azure with caches locally for user login. So basically, we didn't use the virtual machines mainly because they're really expensive. If you want to say SQL always on a set of 3 VMs, it can run very pricey. So we do use the SQL Azure just because it was so cheap, $100. And then with the local cache, we got the availability we wanted, which is if the SQL instance were down, you could still log in, but new users can sign up. Just user login and tenant information. So if you come sign up and say, hey, here's payment information, that stuff goes to SQL, we encrypt it, store it there. Whereas all metric data goes to Cassandra. That's the data associated with our distributed cron job system, which is also that's now baked into the Azure scheduler.
That's not a big amount of data.
Yeah, very small. Yeah. Yeah. So we just use Azure tables because they're like super reliable. Like from an endpoint that I want to save a key value, that's always there. Like Azure Table Storage is just phenomenal. Like 4 or 5 nines is what we've observed. I know the SLA is only 3 nines, but it does really better.
And right now, the building of cluster, is it what's used to be auto scale or is it one maximum that we need?
Yeah, those metrics of auto scale, we now use some internal stuff. So if you use the portal, you'll see that it's just that's actually backed by it. And then, how do I do the time? Yeah, I think we're running out of time. So, yeah, and then anyone, if you that's my email address, it's my Twitter handle. If you have any more questions about running Cassandra on Linux or anything running in Azure, feel free to reach out to me. I'll help and also connect you to the right people. So yeah, thank you for having us today.